Hey guys, sorry I'm gone today. I'm over at district office the whole day, but I wanted to say thank you to Mrs. Kimball for being here today, and she's going to help you out a little bit. Um, I'm only going to be able to go through one problem on this recording system, but you'll see how it's kind of bringing everything together that we did yesterday, and then bringing it to where we can actually graph without a calculator. So we'll try. There may be points, especially on the one problem I'm doing today, to show you that you may need a calculator to help you get some points on there, but it won't be too bad. I just want to make sure you kind of understand what's going on. And Mrs. Kimball is going to go through a couple more problems with you, and then we'll kind of go from there. Of course, if we have any questions when I get back on Thursday, we'll take care of it then and just make sure we understand what's going on. Just a reminder that we are looking at a test coming up on Valentine's Day on the 14th. So just kind of keep that in the back of your mind. But just wanted to give you a heads up that we're getting closer and closer to that, and bringing all of these things together is kind of difficult, but I want to make sure you know what's going on. First things first, yesterday we talked about asymptotes, finding x and y intercepts, finding holes. We didn't graph yesterday, but that's the goal of today. So we'll see a little bit what's going on and kind of go from there. Big thing is you have to remember your asymptote rules. Vertical, you can find in the denominator. The horizontal, you have to use the three different cases and figure out where the degree is either bigger on top or on bottom, or if they're the same. Finding holes, of course, that means you have to factor. Always, always, always factoring to see if something eliminates. Remember, if it eliminates, it is a hole. And then we're going to use all these things that we have found to graph this thing. I cannot stress to you enough that organization is going to be key here. I'm going to show you through the one example how I organize each of these problems. And when we do get to the test, you'll see that this is actually very similar to how we have it set up. It'll be formatted just the same on those tests. So probably a good idea to organize that work in a very similar fashion. That being said, let's go ahead and take a look at this first problem. We have x plus 2 over x squared minus 1. Clearly, the first thing we have to do is go ahead and factor. Well, x plus 2 stays the same. This is x plus 1, x minus 1 in the denominator. Big thing here is nothing eliminates, so not a whole lot of work here. We know that this thing is going to have no holes, but we can continue to organize our work and kind of figure out what's going on here. I'm going to go ahead and sketch a graph. Sorry, not a very straight line. Let's fix that. A little bit better. So I've got my axes. We're going to use this here in a minute. But before we can do that, I'm going to show you how I organize my work. We're always going to have to find those x-intercepts. We're always going to have to find the y-intercepts, the vertical asymptotes, horizontal asymptotes, slant asymptotes. Remember, we may have to find those, and that could come into play if the denominator's degree is exactly one less than the numerator. And then we also have to go ahead and check for any holes, which we already established there aren't any. We'll get to that in a minute. And then we'll actually sketch the whole thing. But this is how I like to organize my work. It keeps it nice and neat, and I can use all of this information to go ahead and graph my rational function here. So first things first, finding the x-intercepts, the zeros. We talked about it yesterday. The easiest thing to know, and in my opinion, this is the easiest one, it's just the numerator set equal to 0. But you have to remember x-intercepts are points, so you have to write it as a point. Well, if I just look at the numerator, set it equal to 0, x plus 2 equals 0, so that means x has to be a negative 2. So negative 2 comma 0. If I want to find the y-intercepts, we know that you just plug in 0 for x and solve for y. Well, if you plug in 0, you get a 2 on top, a negative 1 on bottom. Well, the 2 divided by negative 1 gets you negative 2. There's your y-intercept. It is possible to have x and y intercepts and have multiple of them. So you have to be careful with that. The y-intercepts can't really have multiple of. X-intercepts could always happen. We check for vertical asymptotes. Vertical asymptotes, horizontal asymptotes are always lines. So you have to write them as lines. Well, vertical asymptotes are pretty easy as well. You have to look in the denominator, set each piece equal to 0, and solve. What's nice here is we have x plus 1, x minus 1, which means we have vertical asymptotes at plus or minus 1. So x equals plus or minus 1 is a perfect answer. If you want to separate them, you can do that. I'm okay with that. But like I always say, we're lazy, and plus or minus 1 works just the same. Then we have to look at our horizontal asymptote. We go through our 3 rules, checking for where the degree is bigger, and we see that it's in the denominator. If it's in the denominator, it's automatically a horizontal asymptote at y equals 0. We filled up most of the things here. So the nice thing is the last 2. Slant asymptotes only happen when the denominator's degree is 1 less than the numerator. We don't have this in this case, so I can write none. Holes are when something eliminates top and bottom, and we don't have that here either, so none as well. And here comes the tricky part, is actually taking this thing and sketching it. When you sketch one of these functions, I'm telling you right now, please, please, please always graph the asymptotes first. It's just going to make your life a whole lot easier. So if I'm going to graph this thing and look at my asymptotes, I'm going to actually go, oops, apologize for that. I'm going to actually go and graph those asymptotes first. Well, I have one at 1 and -1. And again, they're always indicated by a dotted or dashed line. And I need you to label them. So x equals 1. Here's the other one. Oops. X equals -1. We have those asymptotes there. Of course, I want to put my horizontal asymptote there. We know it's the x-axis. Y equals 0. I have all my asymptotes on here. And so now we need to start graphing the other pieces we know. I'm going to go ahead and put the x-intercept on there, and just bear with me for a second. I know it's an asymptote, but we'll talk about that here in a moment. Put your x-intercept on there. You know it's at -2, 0. There's my x-intercept. My y-intercept is at 0, -2. There's my y-intercept. And really, of all the things we have at this point, there's not a whole lot else to put on there, and we have to figure out how to graph this thing. Before we do that, though, I have to talk to you about that x-intercept. Ever since you have done any math with any asymptote ever, we've always said it cannot cross it. Well, every teacher's lied to you. You can cross a horizontal asymptote, and in this case, you see why. To be honest with you, I have looked and looked and looked and researched all over the place to a mathematical definition as to why it can cross an x-intercept, and to this day, 3 years of searching, I've yet to find a definitive answer. You just got to trust me on this one. Your calculus teacher next year will say the same thing. We'll go through that. She'll go through that, and it's just a fact that you have to understand. You can cross a horizontal asymptote. Vertical asymptote, you cannot cross. That is always going to be true. Slant asymptote, you cannot cross. But horizontal asymptote, it is acceptable to cross as long as you have proof of it. In this case, our x-intercept proves that it is going to be able to cross. So please just trust me on that. We have kind of a weird case here in that we have 3 areas that we're going to have to graph. If you think about it, I'm going to go off to the side over here in this little rectangle I've got over here. If I think about the general case, f of x equals 1 over x, and I were to sketch the graph, I know it looks something like this. So possibly our graph will look something like that, and it has 2 areas in this one over here. But this graph we have over here is going to have 3 areas, something on this side, something in the middle, and something on this side as well. So we have to find all of these different pieces, and the only good way to do that, unfortunately, is going to be an XY chart. I know they're kind of tedious, but you have to understand what's going on here, and the only way to do that is with an XY chart. So I'm going to scroll down just slightly. We're going to get our XY chart going here. And you just have to be smart about what points you put in there. Obviously, we need something less than -1. We already know -2, so maybe -3. If you want to do -4, you could do -4 as well. But we know at -2 we have 0. -1 is our asymptote. So you could technically do -1.5 if you wanted to. Then if you look over there, we could do 0, but we know at 0 our y value is -2. So maybe do -0.5. We know at 0 we have -2. You could do 0.5 as well, just to see what's going on either side of that y-axis. And then again, you could jump over to the other side of that asymptote and do, I don't know, 2 and 3. So you could sit here and you could plug all these things in if you really wanted to. If you do that, and I'll show my work on here. If I plug in -3, well, if I plug in -3, I have a -1 on top. And -3 squared, that's going to be 9 minus 1 is 8. So at 3, -3, our y value is -1/8. So I go and I plot that point. -3, -1/8. So of course you're approximating that. And so you have something that looks like this. You have these 2 points here. And eventually you'll get good enough to where you know what's going on and you can just graph at that point on that side. But probably nice to know what -1.5 is in there. At this point, if you really wanted to use your graphing calculator, you could. To figure out what that y value is, you just plug in -1.5. What I did is I just went to my table and I'm plugging it in my table. When you plug in -1.5, you actually get 0.4. So you could put 0.4. You could change it to the fraction if you wanted to, 2/5. I might do that just because decimals and fractions altogether are just annoying. So I could graph another point on there, -1.5, 0.4. Kind of looks like that. I get a general idea of what's going on over here. And I know I can't cross that vertical asymptote, so it looks like that. We need to look at that middle part. And if we look at that middle part, I've got some points in here. And I want to plug in -0.5. When I plug in -0.5, I actually get -2 as well. So I've got -1, here's 0.5, so maybe it looks like that. And then at 0.5, I also get a decimal, but it's -3 1/3. So you're getting in this and you're just building this for yourself. If you want to use decimals in there, that's fine. I'm not going to grade you on that. But that's good enough for me. I mean, I have -3, -4, -3.3 is right there. So something's happening in there. And if you were to look at it and just kind of guess the trends as to what's going on, something like that is happening in there. Kind of parabolic, kind of interesting in there, but the only way to figure that out is to plug in points. Of course, we need to finish it by going to those other, the other side of that asymptote. We have 2 and 3. If you plug in 2, you get 1.3 repeating. If you plug in 3, you get 0.625. Well, there's 2, there's -1.3, so maybe here, 3, there. And it's probably going to look something like that. Oops, sorry. Kind of a lot. That's a good problem. That's a hard problem, one of the hardest you'll see, and that's why I wanted to look at this one. But the biggest piece is actually knowing to get all of these things off to the side to help you get started. Once you get started plotting those vertical asymptotes, horizontal asymptotes, slants if you have them, and of course any holes, which we talked about yesterday. And then making your XY chart if you need to be able to find those points to make this thing work. Again, you can always cross a horizontal asymptote. Ideally, it's going to be at the x-axis is when that happens 90% of the time. So look for that every once in a while. But then you just plot your points and graph it and kind of see what's going on. It is a tedious process, but it's not horrible. Mrs. Kimball is going to go over a couple more problems with you. She can either do it on the smartboard or on the backboard, doesn't matter. It's completely up to her. Continue to take notes on that and then work on that assignment for me, and we'll get back together Thursday and see how it's going. Sorry again, but I'm over at district office. If you guys need anything, just email me and I'll try and get back to you as soon as possible. Have a great day.